Good morning. Welcome everyone in the next session of application of geographical system. Is maybe some of you are already aware of the GIS, but today we will try to understand about the GIST, which we called. Let me start with the select the color. So we will try to understand GIST. So how we can apply the geographical information system within transportation. In today's session, first of all, I will try to introduce you about the GIS, what is the nature of geo information system, how we can deal different spaces in time, and what kind of challenges in GIS we do have. But before to go in a detail, I will just give you overview of my research, what I did while using different network models while incorporating all those results within geographical information system, or which we call GIST, or which we also call the ARC GIS as well. Okay, so those are the different versions in the tool which we can use to compute different kind of a numerical and complex problem within the transportation. To go in a detail, as you can see here, before to go into those details, I will try to understand in a very simple and brief word that what is basically GIS in T. Okay, so whenever we talk about GIS, so this is basically the art of engineering and the art of a science, art of engineering plus science, uh, which connect with the technology and which provide the answer to our question in the geographical way. In a very short and simple and precise word, when we represent something which have the geospatial or geographic data or geospatial data or geographic locations of those features is called GIS. So basically, GIS or Geographic Information System is a computer-based tool which have the capacity to, first of all, we need to input those device, insert those device, and then it have the capacity to store it, and then it have the capacity to analyze it. Okay, so GIS is basically the computer tool which have the capacity to visualize, analyze, and interpret geographical data. Okay, so now why do we need to interpret that specific data? Because we would like to draw the kind of a idea from which we can get our desired information. As you can see here, this is the typical network flow of a GIS. First of all, we need the special data modeling along with the quality assessment and then the special data handling. So basically, this is the second representation of that graph number one. Okay. So for example, in the input, we do have to define the space, data, model, and then measures. And then we need that kind of a storage. So this is basically the integration. Integration means when we insert that specific data, and then it is integrated for the purpose to visualize it in the geographical manners, in the geographical way. Uh, we have, if we try to understand that how GIS or that specific graph basically work. So GIS, basically people use GIS for the specific related data or in which we can draw different roads, countries and boundaries. Okay, and then first of all, we have the people. So those people use GIS like me and you people, all those listener and all those who want to learn it. So for example, we would like to insert the data such as the collection of data and also to develop different procedure and also to identify different research question for the purpose to define or achieve the specific analysis. And then second part, we do have the data. So GIS basically function in a two main data type. One is called raster data, and the second one is called vector data. Okay. What is raster data? Raster data is basically the data which is stored in the form of electronic images. So those images could be taken as the aerial messages or from the drone or from the satellite. And then we have the vector type for data or storage. So vector is through which we can identify that at that specific point we have a specific node or network or point or lines or like polygon, or we have the square or we have triangles. So we represent the data in the descriptive way. So this is basically the vector form. And then we have the third stage, we have the analysis. Okay, so this was number one, this is number two, and now we have the number three. So what is analysis? Analysis is actually the process through which we use the special data to answer different questions. Okay, and then we have the hardware part. For example, when we currently we are running our kind of framing or aiming or computing any type of a numerical problem within GIS tool. So we need a type of a hardware which could have enough memory and also the computing power through which the special data, which also include different attributes and different system capacity. So that is basically the part of a hardware. And then we have the software. So basically, GIS is the software which which requires specialized kind of a data, or which we called ASTDR, stdr, which also include the ArcGIS along with QGIS, and also different version of GGIST as well. So those are the different programs which can be used to conjunction with other software, such as different databases, statistical packages, and different programs through which we can design our main problem. Now, as you can see here, what is GIST? So you can imagine your graph from a very single U-turn or intersection. For example, this is our one single network node. This is our single node, and this is our single line or like network. So when we connect such type of a multiple nodes together, it looks like that. And then when we insert different features in terms of a line length, capacity, width, height, bridges, and so on. So at the end of a day, it looks somehow like that. The same concept we usually use it for to draw different type of way. For example, motorway intersection, if they are in the inclined way, if we have the freeway situation. For example, if we want to connect the connection of the main road along with the motorways, or if we want to connect two main roads together, if we want to connect secondary road with the main road, if we want to connect main road, secondary road, and the minor road. So we can compute any kind of a data in the GIS. So that specific GIS have the store physical feature, which we use those attributes in the planning, such as geometric characteristic, traffic. GIS could can also be used to determine the short path analysis. Either that could be in term of a time, that could be in term of a cost, that could be possible in term of a distance as well. Okay, so it is completely based on the number. For example, as we mentioned in the previous slide, that all those when we input during the input of data, we provide all the information in the form of for example, number of lanes, width, capacity, density, volume, and so on. Okay, So the number of lane and their height is already inserted, so we can determine different short path analysis, which will be incorporate different types, traffic lights, on off road, etc., to determine or to give you SPA from any origin O to the any destination J. Okay, and then we have the vehicle routing (VR). So vehicle routing is basically to find out the such type of a stops or depot, or to increase the any vehicle capacity within service time, and also to reduce the kind of a empty run between any 2 point. Okay, so that could also be used in the transportation planning and networking optimization. And then we have the arc routing. Arc routing basically works on the three important functions. The first one is try to compute to on the basis of the optimal matching to satisfy the demand between any 2 point. So, for example, to reduce cost, okay, and also to reduce distance, and also less usage of vehicle. Okay, so the arc routing is actually working on the to find out the optimal and transversal route, and that could be used for the different services such as like delivery and collection and so on. And then the next part we have how we can parsing, clustering, and um to regionalize that data. So to create different regions such as different territories, landscapes, or different district within the databases through which we can identify or like give the equal kind of a function, which we call the balance function as well. So this is basically partial. For example, in a very simple word, if this is our study area, how we can divide that, okay, in like different regions. For example, if you would like to point out something here, or if you want to add any specific data, so we only need to like insert new data or information within specific location, and then we have the clustering of the same data. So when we try to understand clustering is basically uh, the tool or the way through which different algorithms, especially which work in the regionalization of the networking, which could be treated, which are a bit less effective uh, and uh, and also more realistic for the non-planar network if the same networks are basically not kind of a identified. And then we have the intelligent vehicle highway system. So we can also use the GIST package, for example, to identify if any mishap is happen at the motorway, if any accident happens. So we can also use it in the IVHS as well. And also we can locate the vehicle locations as well for the purpose to like dispatch different short route identification system, and also to reduce the empty run. Now I will just explain my one of the case study which we did for the Beijing city. So how we have computed that specific. For example, the first thing first, we are trying to show that the Beijing transportation network is like very complex and complicated, and through GIS and different road network analysis, which suggests that how we can connect the those two cities together, Beijing with the Xiong'an, which is the new project which is called Jingjinji. Okay, so the purpose of that project is how we can connect Beijing. So Beijing will only be the working capital, while Xiong'an will be the auxiliary capital where people will only live. So our task or project was identified that how we can transport like millions of people on the regular basis from Beijing to the Xiaoying on. Okay, so for that purpose, first of all, we have identified different like route one and route two, which were derived from GIS, and we have also identified the different ring roads as well, which is because Beijing is divided in the different sections. As you can see here, if we are trying to understand the population density, it's also presented in the different way. So that part is called the legend. That is our working part, okay, and where we can show different information according to the geospatial locations, which actually give you the exact locations as well in terms of the XYZ location. And the same, for example, if the same legend we would like to identify it in like different colors, while we can use it for the forest as well, also to locate sea, city, roads, and also we can draw our own buffer system as well, and also where we want to connect it. Okay, so all those information could be draw, could be computed, could be analyzed in the ArcGIS. If you can see here, so the same. So this is basically the way the tool, just to give you the kind of a brief demo that what we can do in the GIS. Okay, so we can also show the vegetation area, open area with like grass, with like water, where the station we do have. So each and every kind of information. So that part is called like legend, and that part is called basically the working part where you actually show all those you actually draw all those information. Okay, so there is a saying that every picture should speak itself. Okay? How we can connect through different high-speed railway lines with like different roads. As you can see here, for example, this is the typical example of like that small city Guan area. So through which we can show or we can draw one multiply 1 kilometer grid, and we can I can show you that where we have the maximum population. So each and every legend is actually representing or give the information about that specific figure. That is the usage of like for GIS. Okay, is you can see here. So all those information are without explaining and representing, each and everyone can understand it what is its purpose. As you can see here that those lines were basically drawn to determine the slope percentage, to determine the vegetation, to determine the elevation, and then settlement percentage at the different levels. Okay, is you can see here each and every information, each and every point actually give us the different information. Okay, so it's very much important that we should use that specific legend in every figure with much more care and attention. Now coming to our today's session, this was all that what we can do or what we did in like past. So now what we can do. Okay, basically the GIS, this is the your working tool, which will actually look like that. Okay, this is our storage base, which we call database, and this is our database part. First of all, it will look like that. Okay, so special data, or which we also call the geographical data, or we also call that geospatial data. So that provide the at the kind of a location. Number one is location, and then features, location and feature, and along with that also the boundaries as well. So boundary of each parcel. For example, that specific parcel is like related to recreation. That specific parcel is related to school. This is, for example, commercial activity. This is playground. So each and every parcel or like locations or like feature is changing according to the land parcel. Okay. So how we can analyze this is very much important. Always we need to frame the analysis for like five main purposes. The first one is, first of all, we need to frame any question. For example, always you need to ask that what you want to do. Number first, frame question. Second, explore and prepare the data. First of all, explore and then input the data. And then third one we have choose analysis. Which tool method you will use to get that data. And then number four, analysis. And then number five, examine. Examine means we need to see that the achievement or all the objective what we did is actually the real representation what we have achieved through GIS. If not, then what we need to do, we need to a bit refine or all those three steps unless and until we did not kind of achieved or desired results. The next part is that how we can get that data. Okay, that doesn't mean that at work by itself. A lot of geographical information system, different boundaries maps are already inserted. So we just need to use it smartly. So those are different kind of a satellite which are used, which could be used for the observing different data at the different spot. Okay. So this is, for example, how we can bring something from reality to the mental map. Mental map means, as you can see here, this is just a graphical representation that how you can see it. But in like reality, it is something else. Okay. So as you can see here, so this is very minor stage. This is like very like major stage, or which we call macro, and then a bit micro, and then very like nano micro analysis. Okay, as you can see here, for example, we are trying to go through that specific route from here to like here, and then when we a bit zoom, so we somehow reach to like that specific location. When we zoom that spot more, so this is looks like that. Okay. So this is the one of the product which is for all and which could be fit within each and every scenario. Now we are coming a bit toward more realistic information that how it looked like. The first one we have the entities. So those are the three different type of a nature of geo information. First one is called entity, phenomena, and then field. What is entity? Entity is basically a set of specially discrete object. Object means cities, roads, river, bridges, etc. As you can see here. Okay, so this is entities, and then we have the phenomena. Phenomena is basically a set or the set of instruction which predict the future, which is happen or which could be happen, as you can see here. So this is more like erosion, urban growth, or like fire, or like floods. So this is the phenomena, okay, which we also need to consider. And then we have the field. A field here, you can see here. So a field is a set of specially continuous function in terms of a space, time, air, temperature, soil, moisture, etc. So when we insert, for example, first of all, we were here, and then we reach only to like that spot, and then we are here now in the field. So we are trying to insert. So we need to insert the data of each and every cluster or portion one by one. Then it could be work. As you can see here, so we have the different type of dependencies. So whenever we are trying to insert any data, it doesn't mean that each and every picture look like that. Okay. First of all, we need to insert all the data related to hydrology, topography, land use, utilities, soils, street, district, parcels. And then we need to see it that where all that data specifically could be fit in. And then that specific image could somehow look like that. Okay. So it is different. You can call it different layer system as well. And each and every layer give you a described geographical characteristic. Okay. So here you can see the different philosophical view in the respect of cognitive and in the respect of socio-cultural views. For example, first of all, this is the globe. This is our one satellite, okay, and this is our transmitter. So at a very specific point, we are receiving data here, and then we are trying to merge it according to our own study area, and then somehow we are working somewhere here. So first of all, we have the philosophical, and then we are trying to connect it with the social cultural views. And this is the so like there is no single objective through which all which is same for all, but of course it is different according to the different cluster and different boundaries. So for example, if someone asks from a children that how you will draw a the whole world, so what he can see like fish, ship, different type of a kind of a pandas, penguin, and then cats and different turtles and ships and elephant and camels, etc. So this is his world, okay? But he draw it. So we have the same way of representation, but in GIS we somehow when we draw it, so it look like that. As you can see here, so what we are actually interested in geographical information system when we are talking about GIST. So we are trying to identify different networks, capacity, width, volume can hold, density, length, infrastructure type, temperature, soil, etc. So each and every facility can be conceptualized here. And then at the end of a day, it somehow look like that. Okay. So again, this is your own representation. That doesn't mean that each and everything is going very good. So of course, we do have different challenges as well in GIS in terms of we somehow sometimes need the calibration and validation of the data as well. So the first and main issue is how we can model and handle the data in terms of a time. So basically, the popular or which we call the time slice model, which consists a sequence through which where we may or may not miss some event. For example, if any activity is going somewhere here and we are trying to identify from like GIS from satellite, so it is somehow merging it like that spot. So we might not reach to like that location. So this is the one issue which we call the issue of a time slice or the time event. And then we have the non-metric space as well. So how we can identify different issue and event in the non-metric spaces as well. So each and every area is coded with the geocoding locations. So when we are bound to reach to like that existing area, so proximity among set of places which cannot be properly represented by different networks. So we might lose issue or we might lose data in terms of a travel time and but not in the distance. So in the distance way we can get it, but in the time, so we have the uh, proximity. And then we have the modeling and handling of inexist. in exact space and time. Okay, so this problem has usually been treated in terms of fuzziness and uncertainty. So the state of our knowledge about those property may or may not be accurate. So we are not certain. So for example, if someone tell you that like 200 people are like living here, so how much people will actually live here? So we don't have access to like that spot. So we just say like 300. So that could be 500 or that could be 100. So we are not certain. So our results are based on the uncertainty. Uncertainty means inaccurate, which could be accurate or which could not be inaccurate. So again, translating multiple and sometimes conflicting insights into the data model and to the determine your relevant set of data is sometimes not possible. So this is very big challenge in the GIS. Thank you very much. In the next session, we will get back in the more tutorial way. So if you have any question, you can get back in the comment section. Thank you. Have a nice day.